Hi guys, welcome back to CalcFly videos. We're back with another video. In this video we're going to be talking about question 4 from the 2019 AP Calculus Free Response section. Alright, in this problem, so basically this problem is mainly about the related rate problems. So in this problem we have this cylinder, and this cylindrical barrel with a diameter of 2 feet, which means the radius is 1. Contains collected rainwater as shown in the figure above. We also know that the rate of change in the height of water is given by this expression, dH over dt is equal to -1/10 times square root of h. Alright, so let's quickly dive into part A. So in part A it says find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. So basically what we know, so h is 4 feet. The other thing that we know is dH over dt, which is the rate of change in the height of the water, is -1/10 times square root of h. So basically, in order to figure out this problem, we're going to be benefit from this formula. Volume equals pi times radius squared times height. But in this case we know the diameter, so we also know the radius because radius is half of the diameter. So this volume is going to become into pi times 1 squared times height. So it's going to be equal to, just from here, volume is equal to pi times h. So now it's time to take the derivative of both sides implicitly with respect to time. So let's do it. So dv over dt, it's going to be equal to pi times dH over dt. We already know what the dH over dt, which is -1/10 times square root of h. So if I take this and substitute over here, what we're going to get is dv over dt, it's going to be equal to pi times -1/10 times square root of h. It's going to be equal to -pi times square root of h divided by 10. So we need to also evaluate this derivative at h equals 4 because the height is 4 feet. So this is going to be equal to -pi times square root of 4/10. As a result, it's going to be equal to -pi/5. So what is the rate for that? The rate is for that is the dv over dt. It's going to be equal to -pi/5 cubic feet per second. So cubic feet per second. Okay, so in part A we benefited from this volume formula, pi times radius squared times h. So since we know the radius, which is 1, so I plugged in right here, so we got this. The volume is equal to pi times h. Then I took the derivative of both sides with respect to time implicitly, and then we ended up with this. Then I substituted the dH over dt right here. So we got this, and then we evaluated this expression when the height is equal to 4, and then we ended up with this. So dv over dt is equal to -pi/5, and my rate is cubic feet per second. Okay, so let's move on to part B. So in part B we're being asked this question. It says when the height of the water is 3 feet, so height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So in this case we are focusing on the rate of change in dH over dt, which means, so see, we're going to take another derivative with respect to time of dH over dt. Okay, so which is going to be equal to -1/10 times 1/2 times square root of h times dH over dt, since we are taking the derivative with respect to time. So this is -1/20 times square root of h times -1/10 times square root of h, which is dH over dt. Okay, and as a result, this is going to be equal to 1/200, which is bigger than 0 because we end up with a number that is, positive, which is bigger than 0. Alright, so my reasoning, since dH squared over dt squared is bigger than 0, because it's equal to 1 over 200 for h bigger than or equal to 0. The rate of change of the height is increasing, because we ended up with a negative number for the rate of change, is increasing when the height, when the height is 3 feet. That's the answer. So part B, we've took a look at the rate of change in dh over dt, which is the second derivative. So we ended up with this answer, as you can see, which is 1 over 200, which is bigger than 0, which is positive. So since the rate of change in dh over dt is positive, because it's increasing when the height is 3 feet. Okay. All right, let's move on to part C. So before we move on to part C, I need to clean up the board. All right, in part C, we're being asked to find this problem. It says at t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So if you remember that, originally our equation is given like this: dh over dt, which is the rate of change in height of the water, is given by this negative 1 over 10 times square root of h. So basically we're going to try to solve this differential equation using a separation of variables. So when I do that, it's going to be equal to dh over square root of h is going to be equal to negative 1 over 10 times dt. All right, so this expression, if I integrate both sides, because we have successfully managed to separate the variables on both sides, so the next step is integrate both sides. So when I integrate both sides, we're going to get 2 square root of h equals negative 1 over 10 times t plus c. So my ultimate goal is to solve this equation for h. Basically, we need to isolate h. So square root of h is going to be equal to negative 1 over 10 t plus c divided by 2. So we got to get rid of the square root of, so we're going to take the square of each side. So we get negative 1 over 10 t divided by 2 to the power of 2. So basically, this is the general solution. So this general solution is going to give us the height of the water at any time. But since we are given this initial condition, because it says at time t equals 0 seconds, the height of the water is 5. So basically, 5 is going to be equal to, for t, I'm going to substitute 0. So it's going to be equal to negative 1 over 10 times 0 plus c divided by 2 to the power of 2. So if I solve this equation for c, I'm going to end up with this value, which is c equals 2 square root of 5. Then if I take this 2 square root of 5 and plug in here, we're going to get the particular solution, which is h is equal to negative 1 over 10 times t plus 2 square root of 5 divided by 2 to the power of 2. Okay, so basically this expression is going to give you the height of the water at any time. Alright guys, in this video we talked about how to solve question 4 from 2019 AP Calculus free response portion. Thanks so much for watching. Please don't forget to subscribe, share, like, and comment. Bye bye.